basic matrix operations are, well, they're pretty basic. And when I say basic, I mean we're going to basically be adding and subtracting and multiplying on a very limited scale. So let's jump into it. You operate two small t-shirt booths at opposite ends of the mall. One's on the north side, one's on the south side. And here's your stock. This is what you have in inventory. You have small, medium, large, and extra large, some blue, some gray, some white. So again, we're going to use matrices to organize this data because it's going to be a sloppy mess if we don't. So we're going to write two matrices named N and S. N is north, S is south, and let the rows represent size. That's important. We need to know how to configure this, and the columns are going to represent color. So we're going to write two of them. I'm going to write them in purple. I don't know why. So N, capital N, is going to be all this information here, but strategically written. So let's make sure we understand what they're asking. The rows represent the size. So rows run horizontally. So I'm going to have small, medium, large, and extra large. So we'll just put an S, an M, an L, and an XL. And we're going to have 4 rows. And then we're going to have blue, gray, and white. So we'll put blue here, gray here, and white here. And we're going to have 3 columns. So if someone was to say, hey, what are the dimensions, or what is the order of this matrix, you would say, oh, it's 4 rows, 3 columns, so it's a 4 by 3. So here's the easy part. We're just going to write the numbers in the right place, make sure we copy this correctly. 6 blue, 7 gray, 5 white. 5 white. And I didn't throw any tricks in here where I switched up the words and you had to really make sure that everything was in the correct order. It's all in the right order. But now this is much, much neater and easier to look at. 2, 3, and 5, 4, 8, and 7. There we go. So that is your inventory on the north booth of the mall. And then we also have another one. It's the south booth. And same stuff. So S, not to be confused with this S, M, L, and XL. And blue, gray, and white. And white. And we're going to copy this information here into this one. And we just have 2 very organized arrays of numbers. I used to use that word a lot when I was defining this. It's a rectangular array of numbers, which made no sense. However, in computer programming, you would encounter the word array, and it really is like a matrix. In case you needed to know that. Okay, there we go. We have all our data in there. Everything is correct, and we're good. Now, I do want to point out something before we read any more, before we do any more problems. I think it's important to note a couple things. That we have 2 matrices that are, other than the numbers, they're identical. They're both 4 rows, 3 columns. They're 4 by 3. And not only that, but the rows represent the same thing. So row 1 is small for both of them. Row 2 is medium, then large, then extra large, and then blue, gray, and white. So we not only have the same matrix with different entries, different elements, we really have essentially the same dimensions with the same representation, right? Okay, so here we go. What is N32? What is S32? Okay, now we've done this, so let's just make sure we understand. 32 and 32, well, third row, second column, and if you don't find it necessary to write this, that's cool, but I'm going to write it one more time. This is my row. This is my column. It looks like 32. It's not. So N32 is third row, second column. So if you were to pull out a pencil, you'd be like, oh, look, third row, second column. Yay, it's a 3. Yay. All right, that was not that hard. Just got to visualize it. So what is N32? It's 3. And I would love to write down all kinds of stuff, but I'm not. S32, same thing. So third row, second column, and that's 2. So 2, and I'm not writing down extra stuff like this represents this and this represents that, because I'm going to finish reading this and we'll talk about it. If I were to add these numbers together, obviously I'd get 5 because all of us can add 3 plus 2. That's not the problem, but I really want to know what it represents. So it's not enough that I have the number 5. Okay, great. This is a way to organize data. So 5 what? Okay, so let's talk about this. This 3 was large shirts that were gray, and this 2 was, we can circle it over here, large shirts that are gray. And so 3 large gray shirts on the north side, 2 large gray shirts on the south side. So this is the total number of large gray shirts. Large gray shirts. And I'm going to put one more word in here, and that's the total. I have 5 total shirts. North side, south side, total. Okay. So what we're going to do now is some, well, pretty basic matrix operations. See, that's why we called it that. And we're going to add n plus s, and we're going to call this matrix T. And it's going to stand for, well, total. So n plus s. Now, what I normally do is I write the matrices side by side, and then I will add them. And I'm going to do that this time, and I'm only going to do it probably this time, because after this it's going to be like, oh my gosh, I get it. So here goes. I'm writing them again, and you're probably like, I got this. This is not that hard. I'm just adding. I hear you, but I really feel like the very first time we do this, there are so much going on and so many different numbers that it's easy to mix things up. So here's n again. Now I left off the words and the size, you know, the color, the size. I didn't put that. And here's s. 2, 5, 2, 4, 4, 8, 3, 3. And then it said add them together. So we're going to add this and this. No, okay, so let's not overthink this. And I'm going to pull out my green pen that I used to write magical things like dimensions. So I have 4 rows and 3 columns. This is a 4 by 3 matrix right here. Okay? This is a 4 by 3 matrix. And if I was to add a 4 by 3 and a 4 by 3, don't get carried away. Don't be like, oh, 8 plus. No. It's a 4 by 3. Because this is what's about to happen. I am just about to say 6 plus 3. And don't make it harder than it is. I'm going to have 9 right here. So in just a minute, I'm going to fill in 1, 2, 3, 4 rows and 3 columns. And the way I'm going to get each of these numbers right here, where I just put these blanks in pencil, is by adding the appropriate numbers. Okay, so let me jump around a little bit here and do something I've already done. 3 plus 2 was 5, and that came from 3 and 2, and it's 5, and it goes here. And it goes here because that was 3rd row, 2nd column, plus 3rd row, 2nd column gives me 3rd row, 2nd column. Like, really, it's that easy. So without me beating a dead horse, let's just move on. I like to do these kind of moving down. I don't know why, but I do. 6 plus 4, 10. Nobody is surprised at this mathematical stuff. So 2 plus 6, 8. 4 plus 2, 6. I promise it's this easy. So again, this time I'm doing it kind of the long way where I'm writing everything out. In the future, I'm not. I'm going to go up here and I'm going to be like 9, 10, 8, 6, you know, and we'll just do, and we're good to go. Now they're not all that easy, but yeah, you get the drift. So 9, by the way, I'm looking at 7 and 2. Here we go. 9 and 5, that's 14. We've already done 3 plus 2, and then 8 plus 4 is 12. And then we come over here and we say, well, 9. And then 6 plus 8, that's 14 also. 5 plus 3, 8. And 7 plus 3, 10. Okay. They said, they being the people that wrote this, that would be me actually, call this matrix T, and we're going to call it T for total. So I could put like T equals all this stuff. I'm going to put it over here just so I know that this matrix is T. So now I have a total, and then when I get to number 4, I'm going to answer a specific question. I mentioned this earlier, and it's this. If I would have asked you for something that is beyond these dimensions, then it would be an undefined. Like if I would have said, what is T? 10, 6. Well, I don't have 10 rows and 6 columns, right? I'm just throwing this out here just so we know that if I come up with something here that is beyond what I have, then I would say it's undefined because it's not, well, defined. All right, so let's actually answer this question. What is T 4, 3? And that would be the 4th row. So we're looking at these 3 numbers. And then the 3rd column, 1, 2, 3. So it's 10. And I'm not going to just put 10. I want to know what it represents. And what I didn't do on this problem was write down all the marginal stuff. The marginal stuff like small, medium, large, extra large, blue, gray, white. So let's do that just really briefly, just for what we need. Small, medium, large, extra large. This is our extra large. And then the 3rd column was blue, gray, white. So I'm not writing all of it this time. I'm just writing the stuff I need. Fourth row, third column is white. It's 10. So 10 white, extra large, I'll just abbreviate that, shirts. And that's great, but let's really put this in context. I'm dealing with the North and the South. So that's my total.